Welcome to the Explainer. So, if you've ever dipped your toes into modern web development, you've probably typed npm install. But have you ever stopped to think about what's really happening when you hit enter? Today, we're going to dive deep into NPM, the world's largest software registry, a tool that is incredibly powerful, but also, as we're about to see, potentially a little bit dangerous.
Wow, okay, that is a pretty heavy statement. Remote code execution, that basically means that a simple command you type on your own computer could let someone else, somewhere else in the world, run their code on your machine, without you even knowing. So to really understand how a command we use every day could be so risky, we have to start with a crisis that honestly sent a huge shockwave through the developer world. So a few years ago, the NPM ecosystem got hit by this really sophisticated, self-replicating piece of malware, and it was a massive wake-up call for everyone about the blind trust we often put into open-source code. It was named Shai-Hulud, after the giant sandworms from the movie Dune, and this thing was terrifyingly clever. It all started with some simple phishing attacks, tricking developers into giving up their account passwords. Once the attackers were in, they injected malicious code into popular packages. But here's the really scary part, the replication. The malware was designed to steal credentials from any computer it infected and then use those credentials to publish new, infected versions of other packages all on its own. It was spreading itself like a digital virus.
And the scale was just huge. The attack hit over 187 different packages that, altogether, were being downloaded more than 2 million times a week. It was stealing developer credentials, messing with financial transactions. It created this massive crisis of trust right at the heart of the entire JavaScript world.
So all of this just leads to one big question, right? What exactly is this system we call NPM? And how did it get to be so important, so central to almost everything we build on the web today? All right, let's break it down. Let's look at this system that is both the world's biggest software library and, as we've just seen, a place where things can go really wrong.
The thing about NPM is that it's not actually one thing. It's more like 3 different parts that all work together. First, you've got the registry. The best way to think about this is like a gigantic public library. But instead of books, it's filled with millions of little pieces of code called packages. Second, there's the CLI, the command line interface. That's the NPM command you're actually typing in your terminal. It's the tool that lets you go to the library and check out the code you need for your project. And third, there's the website, npmjs.com. That's the online catalog where you can search for packages, see what they do, and manage your account. Okay, so to use NPM safely and, effectively, you absolutely have to understand the 2 most important files in any NPM project. They're kind of like the 2 blueprints for all the other code your project depends on. And this slide right here really gets to the heart of it. You've got your package.json, which is like a wish list. You tell NPM, hey, I need this package, and any recent version's probably fine. But then you have the package-lock.json, and that's the exact blueprint. It records the exact version of every single package you installed, down to the last detail. And this is so important because it prevents something called version drift. That's the nightmare scenario where you and your teammate have slightly different versions of the same code, and it causes these weird bugs that are impossible to find. The lock file makes sure everyone on the team has the exact same code, every single time. It's a lifesaver.
Now, to really understand what's going on in those files, especially with those version ranges, we need to learn the language that NPM speaks. And that language is called semantic versioning.
Semantic versioning, or SEMver for short, is this really simple but powerful idea. The numbers aren't just random. They're a contract between the person who wrote the code and you, the person using it. Each number tells you what kind of change to expect in a new version, which helps you understand how risky an update might be.
And here's how that contract works. A version number has 3 parts: major, minor, and patch. A patch update means small bug fixes. It shouldn't break anything. A minor update means new features have been added, but again, in a way that won't break your existing code. But a major version update, that means there are breaking changes. It's a signal that if you update, you're probably going to have to change some of your own code to make it work.
Which brings us to that little caret symbol, that little hat you see everywhere in package.json. What that caret tells NPM is, hey, go ahead and grab any new minor or patch versions you find. Those should be safe, but it will never automatically pull in a new major version. This is great because it protects you from those big breaking changes while still letting you get the latest bug fixes and features. It's all about balancing stability with staying up to date.
So now that we kind of get the mechanics of NPM, versioning, and these lock files, let's bring it all back to that Shai-Hulud crisis. How can we actually protect our projects from attacks like that?
The good news is you can seriously reduce your risk just by adopting a few key habits. Things like turning off post-install scripts. These are little programs that can automatically run when a package is installed, and they're a huge way that malware gets in. Of course, always use two-factor authentication on your account to stop people from taking it over. And you should get in the habit of running NPM Audit, which is a tool built right into NPM that scans for known security holes in the code you're using. And building on that, one of the single best things you can do for security is use a command called NPM CI. This is especially true for any automated process, like on a build server for what we call CI/CD. Unlike NPM install, which might decide to update your lock file, NPM CI does only one thing. It installs exactly what's in your package-lock.json. No changes, no updates, no surprises. It guarantees that the code you tested is the exact same code that gets shipped.
And that really is the key takeaway here. The amazing convenience of NPM, having all of the world's open source code right at your fingertips, it comes with a responsibility. You are building your project on the work of hundreds, maybe thousands of strangers. In that kind of world, trust is important, but it always has to be verified.